Hey guys, it's Mr. Palmer. I'm back with our fourth problem on the midterm review. This one is going to be a projectile problem. Right? A ball is thrown horizontally from a roof of a building 20 meters high at 30 meters per second. We want to know the vertical velocity of the ball when it lands and the ball's total velocity, speed, and direction when it lands. So let me just do a quick little sketch over here. Get rid of this. We're talking about launching a ball from a height, launching it horizontally to the ground. We know that the initial velocity, if we go back to the question, it says launched horizontally. Horizontally means in the x direction. Velocity, and the problem says that it's 30 meters per second. It says that the building is 20 meters high. Remember, we say high is y. When we're talking about the height, we're talking about the y direction. 20 meters. That's going to be our dy. This is our v in the x direction. So when we're solving something that's going to be a projectile, we want to set up an xy table. So we want to look at the variables in both directions because both directions have independent velocities and times and distances. So in the y direction, because of gravity, we're going to have a if dat. In the x direction, it's constant velocity, which means acceleration is going to be 0. So we don't need all 5. We only need velocity, displacement, and time. So let's set this up. We're going to fill out our table. We've already established that it's a horizontal shot. So we're going to come back and we're going to put in an x velocity of 30 meters per second. And again, horizontal also tells us something else. If it's being launched horizontally, it tells us that the initial velocity in the y is 0, right? That is horizontal. Horizontal launch is 0 initial velocity in the y. We know the height. Remember, high is y, so that's the distance in the y is going to be 20 meters. Now, we need one more piece of information, and because this is a projectile, it's under the influence of gravity. Acceleration. Now, if we're calling the height 20, the ball is falling down and it's going positive 20. That means we're calling down positive. Because this is a horizontal shot, that's okay. If we were going to do a launch up and back down or an angled shot, we would want to use negative 9.8. Here we can simply use 9.8 because it's going down the entire time. So you know 3, you know me. We can establish our final velocity in the y direction. All we need to use is equation number 3. Vf squared equals vi squared plus 2ad. The final velocity in the y is not 0. Right? It's not going to be hitting the ground going 0. It's when it lands. So it's going to have a velocity when it hits the ground. It's the initial velocity in this case that's 0. Plus 2 times 9.8 times the height, which was 20. So if we complete our math, do the algebra, 2 times 9.8 times 20 is going to give us 392 equals Vf squared. We're going to square root both sides, and that's going to give us a final velocity of 19.8 meters per second. Now, obviously that's down. We call down the positive direction. We can write it over here as 19.8 meters per second. That's the answer to part A. That's the vertical velocity when it lands, but it says what is the ball's total speed and velocity, or speed and direction when it hits the ground. And if we look in our table, when it hits the ground, it has 2 velocities. Not only is it going downward at 19.8 meters per second squared, but it's also going horizontally at 30 meters per second squared. So we have to put those two together using trigonometry. So you're going to make your triangle with your v in the x direction first. We're going to put in our v in the y direction second. The resultant velocity is going to be here, completing our triangle, the hypotenuse, and it's going to be at some angle below the horizontal. Our v in the x direction from our table was 30, and in the y direction it was 19.8. So you're going to use the Pythagorean theorem to solve for the hypotenuse. So you're going to put in 30 squared plus 19.8 squared equals c squared. You're going to square root to get your answer, which on this side I believe is 1292, is equal to your hypotenuse, which is going to give you 35.9 meters per second. That's what you get when you're going 30 in the horizontal and 19.8 in the vertical. The last part is to find the angle. Remember, to find this angle, when we know the two legs of a triangle, we're going to use tangent, and that means inverse tangent. Inverse tangent of your y over your x is going to give you your angle. So in this case, we're doing inverse tangent, substituting in 19.8 over 30, which gives you a final angle of 33.4 degrees below the horizontal, and that's where that answer comes from. This is the 33.4 degrees. Our resultant velocity, 35.9 meters per second. And there you are. That's the end of our first projectile problem. We might do a couple more in the future, but we'll move on to number 5.